Good afternoon. Welcome to the Malcolm Renfrew Interdisciplinary Colloquium for Tuesday, March 1st, 2022. It's Mardi Gras in New Orleans and other places, and I wish I could say laissez le bon temps rouler, or let the good times roll, but it really is not a good time for our planet. And today is the first of two programs related to global climate change. And I'll introduce today's speaker in just a moment. But I wanted to introduce myself and my co-coordinator. I'm Kenton Bird from Journalism and Mass Media. Daniel Bukovich from the Lionel Hampton School of Music is one of the founders of this long-running series of programs every Tuesday throughout the academic year. It's nice to be back on Zoom after our brief foray into an in-person event last week. The program today and the program next Tuesday will be on Zoom. We're still determining what the format will be for the programs after spring break. We'd like to do more in-person events and some field trips. But before introducing today's speaker, let me tell you what we have next week, which is essentially a more localized follow-up to what we're going to hear today. So next week, we are going to hear from a panel put together by the McClure Center for Public Policy Research at the University of Idaho. And it's going to be what they call a flash panel, or a lightning series of 6 speakers: Kellen Brown, Chris Cadill, Kelsey Donahue, Patrick Hazenbuehler, Catherine Himes from the McClure Center, and Eric Winford. And they will be helping us localize the impact of climate on Idaho's economy, following up on a report that the McClure Center prepared last year. So I hope you will be able to join us for that presentation. Today, though, we're going to hear from a professor of geography, Jeff Hicke, who has, of course, spoken to this group before about climate change, climate impacts, and significant to today's presentation is that Jeff is a coordinating lead author for the report you see on the screen, the AR6 Climate Change Impacts, Adaptation, and Vulnerability, part of the Working Group II, which is responding to the 6th assessment report by IPCC, the Intergovernmental Panel on Climate Change. And so Jeff is going to talk us through some of the significant findings of the assessment team, and share with us some insights from his own long history of research with climate change. And I hope we'll have plenty of time for questions at the end. So welcome, Jeff.
Thank you, Ken, for the introduction. I'm just going to share my screen here. It can take me just a sec. Get things going.
There it is.
Let me move some toolbars around so I can see and you can see. Okay, you should be seeing my slides and not presentation view. So
Looks good.
Okay, great. Thanks again for the introduction, Ken, and the opportunity to speak at the Renfrew Colloquium. I'm going to talk, as Kent mentioned, about the latest report that discusses impacts, adaptation, and vulnerability of climate change. I'd like to acknowledge support over the last several years from various sources that include Harding Faculty Fellowship, the College of Science, the Department of Geography at the time, and the University of Idaho. So I greatly appreciate their support. I'm going to talk a lot about, or mostly about, information presented in the report, but I will add some things that illustrate some local impacts or adaptation as appropriate. I will first I will start by reviewing the IPCC mission and its process, and then I'll get into 3 takeaway messages and describe them. Okay, the Intergovernmental Panel on Climate Change was created in 1988 by the World Meteorological Organization and the United Nations Environment Program, so it's an international body. Its role is to assess the current climate information, the scientific information about climate change, in a policy relevant way to support decision-making. The IPCC produces full assessment reports every 5 to 7 years. The first one started in 1991. As Kent mentioned, we're on the 6th one now. And the IPCC also produces occasional special reports on, for instance, extreme events, or a notable one recently was on the risks associated with warming beyond 1.5 degrees C. The IPCC is divided up into 3 working groups. Working Group 1, shown on the left here, is the physical science of climate change. They produced their 6th assessment report and published it back in August of last year. What I'm going to talk about is Working Group 2, Impacts, Adaptation, and Vulnerability, which was published yesterday. And then the 3rd working group addresses mitigation of climate change, or how to reduce future climate change. And their report is due out in early April. Working Group 2's report is divided up into different chapters, 18 chapters total. The first set of chapters are associated with addressing different sectors. So all about ecosystems or food or cities or health. The next set of chapters are regional chapters, typically continents, such as North America or Africa, but also small islands and some other important regions. And then the last 3 chapters are synthesis chapters that draw threads from across the report. There were 270 authors that participated in this report who studied and cited tens of thousands of publications in order to write the report. I was part of North America, chapter 14. We had 13 authors with a wide range of expertise, from natural scientists such as myself to social scientists, because we were covering the wide range of scientific topics that you can see in the different sectoral regions. So moving to the first takeaway message, climate change is happening now and has caused severe impacts to both people and nature. I'll start out by showing you some metrics, or one metric of recent climate change. This is the global mean surface temperature anomaly, that is changes from 1850 to the present. So that's the time series. The y-axis is in degrees Celsius, but you can multiply by about 2 to get degrees Fahrenheit. There are 4 different estimates. They're all telling about the same story, very close, which is that beginning in 1900, we've seen substantial warming on the order of 1.1 degrees C, or about 2 degrees Fahrenheit. And that might not seem like a lot, but associated with that warming have been additional heat waves, heavy precipitation that has caused flooding, sea level rise that have inundated coasts, ocean acidification, snow and ice decline, hotter droughts, and so on. So that was all reported by the Working Group 1 report published last August. And our job as Working Group 2 was to understand, document the observed and projected impacts in the future. And so we started with this observations of climate change and identified publications that have attributed that climate change to different impacts. So I'll show you 2 slides, 2 different figures here that are laid out the same. Excuse me. These are impacts, observed impacts due to recent climate change. This particular figure focuses on ecosystems. The rows indicate different regions, so it starts globally and moves through the different continents and regions of interest. The columns are divided into three main areas: changes in ecosystem structure, which are things like species composition in an area or the age of forests. The middle column are shifts in species ranges. Are species occurring farther north or uphill? Or are they contracting at the equatorward edge of their range? And then the last column is changes in timing of events like bird migration or insect emergence or flowering. And so for each of these three main ones, there are terrestrial ecosystems listed, freshwater ecosystems listed, and ocean ecosystems. So that is how the figure's laid out. The dots indicate the confidence that scientists have in attributing an impact to climate change from human activities. So that confidence has been developed based on reading the published literature, scientific literature, and higher confidence represents a lot of studies in agreement. Lower confidence could either mean not very much scientific information is available or understood about that, or that there might be some disagreement in the role of climate change. So the deeper the color of blue, the higher the confidence. And so just squinting, taking a step back and looking at that, at this figure, you can see that there are many places that have experienced many different impacts of climate change in terms of these changes in ecosystem structure, species shifts, or seasonal timing of events. There's a lot of blue dots. There are some areas with lower confidence though too, so not everywhere has experienced these impacts. But again, I was part of the North America chapter. So in North America, there are scientific studies that document with high degree of confidence examples of each of these impacts on ecosystems. The second part of the figure is the same layout, but now for impacts on human systems. The rows are the same. The columns are divided up into various aspects of impacts to human systems. One is the first leftmost columns are associated with water and food. The middle column is associated with health and well-being, and then the rightmost columns are associated with cities, settlements, and infrastructure. The dot colorations are the same. High confidence is indicated by higher, deeper colored dots. But in addition, there are minus signs in the dots or plus minus signs in the dots. And these indicate whether the impacts that were observed are adverse, that is negative for that particular part of the human system, or whether there might be examples of both adverse effects as well as benefits. So again, in many locations, there are documentation and studies that have reported the impacts of climate change across various aspects of human civilization and society. But there are also places where climate change has provided some benefits, not as many as the negative aspects. But to focus on North America, again, many observed impacts, most of which are negative, but some of which also could be positive. So an example might be agriculture, which is this dot here, or crop production. North America has experienced both the negative impacts of recent climate change through heat waves that have damaged crops, but also some areas of agriculture have benefited from additional warming, for instance, that allows newer crops to be planted in areas that were previously too cold. Excuse me. So I pulled out some examples from our North America chapter of some significant impacts and just list them here. There are many, and many that are severe. One is associated with flooding, for instance, from heavy precipitation following storms or hurricanes, but also from sea level rise. We are experiencing in the Western US declines of snowpack, which have affected stream flows and therefore water availability for natural ecosystems as well as people use. Sea ice decline in Arctic regions has affected the species that live there, such as walrus or polar bear or seabirds, as well as affecting indigenous peoples that rely on those animals for food resources or rely on sea ice or river ice for transportation. Obviously, we've experienced a lot of wildfires and smoke pollution. Those have been increasing in recent decades. I mentioned crop damages from heat waves that have cost significant amount in terms of economic damages. The oceans around North America, as well as globally, have experienced heat waves that have altered the locations of fisheries, for instance, and reduced productivity, have increased ocean acidification as CO2 diffuses into the water. And coral reefs have experienced die-offs associated with very hot ocean conditions. And then finally, in North America, we've seen increased incidence of vector-borne diseases, increased morbidity and mortality associated with heat-related deaths, and adverse mental health outcomes associated with anxiety and responses following severe events such as hurricanes or storms. Takeaway 2 is about the future. We expect future climate change, continued climate change, and we expect that that climate change will accelerate and exacerbate impacts. But we also know that by taking action to reduce reduce greenhouse gas emissions, we can limit future warming and thereby avoid the worsening impacts. So to set this up, I'll show you projections of global mean surface temperature again, now using climate models out to 2100. So the time period here is 1950 to 2100. The y-axis, again, is the amount of warming over 1850. 1 degree C or 1.1 is about the amount we've observed so far. 2 degrees, 3 degrees, up to 5 degrees C of global temperature warming. And then you can see the trajectories that climate models predict of this warming given, so given different scenarios. So what's also plotted on here is different emission scenarios, that is choices or scenarios that indicate choices by people in the future that would either result in lower greenhouse gas emissions and lower amounts of warming, as illustrated by this teal color, SSP1 so-called, or continued greenhouse gas emissions that increase the amount of carbon dioxide and other greenhouse gases in the atmosphere and lead to additional warming up to, in some cases, 4.5 or 5 degrees C. So those are the different scenarios that bracket realistic, what we think is realistic in terms of future warming. So now the question is, how did that translate into potential impacts or risks? What I'm going to show you is a series of burning ember diagrams. These are illustrated here with a little bit of a guide. So they are bars that have as their y-axis the amount of global warming that you saw on the previous slide. And then there are colors for each of those global warming amounts that correspond to the risk of a particular impact occurring at that global warming amount. So the risks range from yellow, which are moderate risks, up to high, which are red, and very high, which are purple. And these burning ember diagrams and the associated risks evaluated were produced by authors of the report based on various lines of evidence that include modeling, field experiments, long-term observations, and then expert elicitation as well. So I'm going to show you now the rest of the figure here, which are 5 burning ember diagrams associated with 5 different reasons for concern that have been identified by the IPCC as important at the global scale. So these different reasons for concern are as follows. Number 1 is unique and threatened systems associated with limited species ranges, for instance, or hotspots, or unique indigenous communities. Number 2 is associated with extreme events such as heat waves, flooding, etc. Number 3 is the distribution of impact, which is disproportionately affecting groups that are often very vulnerable. Number 4 is globally aggregate impacts, so some measure of the total number of species that go extinct globally, or the total cost of climate extreme events, or the number of people that are displaced or have been killed. And then number 5 is something about so-called large-scale singular events, which are well, as an example, is the rapid melting of Antarctic ice sheets that raise sea level, or major shifts in Arctic ecosystems, which are warming at a rapid rate, or the significant loss of coral reef systems. So these burning ember diagrams, again, have a y-axis value of a warming level that corresponds to the same y-axis level as the model projections on the left-hand side. And the different colors indicate the risk amount. So again, moving from undetectable to moderate, and moderate to high, and high to very high. Those are the transitions. And so what I'm going to draw your attention to is the shift for each of these different reasons for concern from moderate risk to high risk as some indicator of exacerbating impacts that are represented within each of these reasons for concern. So I put arrows next to those transitions. And I've also highlighted on the left here 3 different warming levels. One, the 1.1 degrees C, which we've already experienced to date over 1850s temperatures. A second, which is actually the 2 degrees C of warming, which was the initial target of the Paris Agreement and earlier agreements. But then more recent studies and reports actually by the IPCC have indicated that, in fact, what we'd like to shoot for is instead a total warming of 1.5 degrees C, which is only about 0.4 degrees C above what we have today. And the reason for this concern about moving from 2 degrees to 1.5 degrees C of total warming is illustrated by these transitions. So for reasons for concern 1 about unique and threatened systems, we are very close, if not already, transitioning to from moderate risks to very high risk, much more severe impacts, higher probability of them happening. If we limit warming in the future to 1.5 instead of 2 degrees of warming, you can see that we avoid the transition to high risks for reasons for concern 3, 4, and 5. They occur with higher levels of global warming than 1.5 degrees C. And for extreme weather events, we actually will expect to see some transition even with a limit of 1.5 degrees C. So the emphasis is on reducing the amount of warming in the future as much as possible in order to avoid these severe risks that may happen. And one aspect of this report that is new is the reduction or the recognition that these transition levels will occur faster and sooner than previous. So then I'll take you through a few examples of North America burning embers. The authors of the North America chapter put together a few of these. This one is related to risks associated with fresh water. So the different bars here represent freshwater scarcity associated with droughts and aerification. The second is snow and ice decline, which limit seasonal flows, especially during summertime when flows are already low. The third is related to heavy precipitation, which results in flooding and significant damage. And then the fourth is associated with water quality impacts, which are, for example, toxic algal blooms that occur and are toxic or harmful to humans and animals. And then again, the risks go, or the burning ember diagrams increase with height as warming gets higher. And I put on the 1.1 degrees C of warming of today and the 1.5 degrees C target. And so again, like I showed in the previous slide, we can avoid this transition between moderate to high risks if we limit future warming to 1.5 degrees C instead of 2 degrees C. And you can also see that there's a little bit of variability about the risks associated with a given warming level. So for heavy precipitation and flooding, that transition won't happen until later or at greater amounts of warming at 2.5 or 3 degrees C. So a little bit buffered in terms of timing of that particular impact, but very near-term impacts with, for instance, snow and ice decline. A second burning ember diagram was produced for economic damages across a number of different sectors. These sectors are agriculture, forestry, tourism, transportation, fisheries, energy and mining, and construction. And again, you can see by limiting warming to 1.5 degrees C, we can avoid transitioning for forestry, tourism, transportation, and possibly fisheries, which will experience significant risks or potential impacts in the future at 2 degrees C or so. You can see agriculture will transition with expected warming in the next few decades to higher risks. So that's a rapid impact that's coming quite quickly. Construction does appear to be quite buffered against future warming levels, moderate risks throughout these different warming levels. And then the last one here is associated with tourism. And I'm showing you this not only for the interest you may have in tourism, but also to show you the effect of adaptation, which is an opportunity to reduce risks and therefore potential impacts. So the two are Nordic skiing and snowmobiling, which are the two bars on the left. Alpine skiing is on the right. And for each of those, there's a burning ember diagram without adaptation, and then a burning ember diagram, the risks assessed when adaptation options that we can see today have been enacted. So concentrating first on the Nordic skiing and snowmobiling, we should see transitions to high risks pretty soon associated with the snow and ice decline that I showed previously. And there really isn't much difference in terms of these two with adaptation without, because we don't really have many adaptation options, at least as of yet. By the way, I should mention that adaptation is action to reduce current or expected climate change. So alpine skiing, there are adaptations to reduce risk to alpine skiing. Examples of adaptation options include making snow or moving chairlifts to higher elevations that happen to be colder and have more snowpack longer in the season. And so you can see there is a transition to high risks for alpine skiing without adaptation with 1.5 degrees C of warming. But if we can implement some of these adaptation actions that reduce the effect of climate change, that transition is pushed out into the future and perhaps avoided altogether if we can limit climate change to 2 degrees C. And then as an example of future impacts, I'm showing you here what happened last summer, which was an amazing summer with respect to climate. So we had in the Pacific Northwest this June heat wave that caused hundreds of deaths in the region, cracked pavement in the region. UI was working hard to deliver cool air through its chilled water system. There was closures of water bodies, including Horniman Pond in the east part of Moscow because of toxic blue-green algae. The hot conditions were threatening salmon, and so there was an effort to truck salmon around reservoirs to help them along their way to the ocean. And then Moscow Mountain was closed for July and much of August because the major landowner there was concerned about wildfire risk. In fact, we did have a wildfire in late August on the mountain. So these events by themselves may not be have yet to be attributed to climate change. I haven't seen the particular studies out yet to human activities, but we know that they are excellent examples of what may happen in the future and may happen very frequently, maybe every year, every summer in the coming decades. So they're really quite eye-opening, I think, about what our future might look like here in the Northwest. Okay, so what can we do to limit these severe impacts? The first thing we can do is what are called mitigation activities. Mitigation activities basically reduce the amount of greenhouse gases in the atmosphere through reducing emissions and therefore lowering future climate change and lowering warming. So it's basically transitioning from these high emission scenarios that result in a lot of warming by 2100 to lower emission scenarios that cap warming at 1.5 degrees or 2 degrees C. Again, through reductions in greenhouse gas emissions. Using the burning ember diagrams, it's easy to see that by reducing that future warming, the risks become reduced from maybe very high or high risks to moderate or lower risks. And this is addressed in the Working Group 3 report, which will be released in, I think, April 1. But this leads me to my third takeaway message that relates to adaptation. And again, adaptation is the action to reduce current climate change or expected climate change. And I'll give some examples in a bit. But the message is that adapting to climate change is possible and effective to reduce future impacts and risks, but progress on adaptation has been uneven. It's been too slow to keep up with climate change, and it does have limits. To describe adaptation, I first want to show you this diagram that discusses the components of risk from the IPCC report. Risk, as you may have been guessing, really is defined as potential impact from climate change to a particular system or sector or characteristic. So an impact is a manifestation of future risk. Another way to think of that. Risk is divided up into climate hazards, which are the average warming over the course of decades, but also related to extreme events like heat waves or flooding or sea level rise. In other words, the components of climate that are changing. The risk is influenced by exposure of people or ecosystems to those climate hazards. So if you live in flood-prone areas or by the coast, you may experience floods or sea level rise, or if you live in fire-prone areas, etc. That's the nature of exposure. And then people and ecosystems are also vulnerable, and that vulnerability leads to risk. So vulnerability is lack of resources, or being homeless or poor, inequality or being marginalized, access to clean water, etc. And it's this combination of hazard, exposure, and vulnerability that leads to risk. And so if we can reduce those components, we can therefore reduce the risk and reduce the probability and severity of future impacts. So adaptation is taking action to reduce those different components, and I'll just give you a few examples here. One is that we can restore coastal ecosystems and therefore limit storm damage associated with rising sea level. We can also add reservoir capacity in the Western US to store water, because our snowpacks will store less water in the future and therefore buffer lower flows or reduce water scarcity. We can reduce people's exposure by moving them out of floodplains or away from coastlines. We can evacuate people during the course of extreme events such as severe storms. We can put in warning systems. All those things will allow people to avoid climate hazards. And then we can reduce vulnerability by reducing poverty, improving infrastructure for energy, water, food, etc. We can upgrade housing to be more flood-proof or more fire-proof. One aspect about adaptation, however, is that actions to date have been slow and uneven geographically. This figure on the left shows you the various stages of adaptation. Those stages begin with an awareness that something may be happening or threatening a particular location. That location then produces an assessment of the climate change that may happen and the vulnerabilities that climate change will increase. Whoops. Assessments lead to plans, plans lead to implementation and action, and then there's the monitoring evaluation of the effectiveness of those plans. And the Forced National Climate Assessment put together this figure to indicate that by 2014, there was some activity through the planning stage, but not much beyond that. But by 2018, there was some limited activities that implement adaptation. But of course, what we need to do is accelerate that if we want to keep up with climate change. So, and then the map on the right here shows locations that have had implemented written adaptation plans by 2020. The green states are states with the adaptation plans in place. The dots are cities with adaptation plans in place, or localities. And so you can see that there's quite a bit of spatial variability about where places are that are planning for adaptation. Examples of adaptation in Moscow include writing a climate action plan, and that has been done and drafted by the city. Improving and maintaining forecasting and warning tools associated with harmful algal blooms that affect water bodies in the area. But also we experience, of course, wildfire smoke regularly, and warning people about that, plus the potential for heat waves are tools that allow people to avoid those extreme events. Helping people install air conditioning units or air filtration units will help people adapt to wildfires and heat waves, and also making available cooling stations and smoke stations during those times. Adaptation actions could include developing new crops that are more heat tolerant or drought tolerant, or crop varieties, and planting those here in the area. And then closing recreational areas to limit the exposure to future wildfires. And of course, that's not a popular option, but it's, I guess the landowners last summer felt it was a necessary adaptation action to reduce the wildfire risk during that hot, dry period last summer. So understandably, that landowner wanted to protect its resources. So I've talked about mitigation and adaptation. Do we really need both? And the answer is yes. We expect some warming in the future, and therefore some increasing impacts. And so in order to limit those impacts, adaptation actions are needed. Adaptation itself is costly in terms of time, effort, and funds, and therefore it's easier to adapt to lower levels of warming and slower levels of warming. And adaptation does have limits. These limits are divided up into soft limits, which are associated with policy or funding. And they're called soft because they are movable with political will or if additional funds become available. But then there are also just hard limits that exceed adaptive capacity. And some of those hard limits might be associated with the collapse of fisheries due to warming water, or human deaths, or species extinctions. And so really what we need are efforts in areas of both adaptation and mitigation. One aspect of the report that was important is the recognition that climate action should include sustainable development. Sustainable development goals are listed here. There are 17 that have been developed by the United Nations, and they include things like alleviating poverty, or increasing equality, or making available clean water. While at the same time, so that's the development part, at the same time recognizing the sustainability part, which is maintaining ocean and land ecosystems, as well as limiting future climate. And so the concept of climate resilient development is discussed in a report, and that term integrates the climate action, that is adaptation and mitigation, together with advancing development in a sustainable way for everybody. And this is represented in this figure that looks a little complicated. What it illustrates are pathways from today, which is illustrated in this period 2022 out to 2100. And these different pathways lead to different outcomes that would result, for instance, at the top here in a lower amounts of warming and therefore a reduced amount of impacts, but also in terms of sustainable development that raises wealth and income, increases society well-being in populations that are currently vulnerable. Another outcome, however, is increased warming and climate change and more severe impacts while at the same time not addressing inequities or injustice and poverty. And so these development pathways, climate resilient pathways, are illustrated by choices that define the pathways. These choices are societal choices, and the idea is that, in fact, we can achieve sustainable development while at the same time building climate resilience. So just to give you some information about more climate change assessments and plans, I've talked a lot about the 6th assessment report. You can see the website there. If you're more interested in what's happening at the US government has put together 4 now national climate assessments. The most recent was published a few years ago. The 5th assessment report is forthcoming, in progress. Kenton mentioned that last December, the Idaho Climate Economy Impacts Assessment was published, directed by the McClure Center, and that's the topic of next week's Renfrew Colloquium. So come back to learn more about the state level impacts. And then I mentioned that the city of Moscow has been active in climate action. The most recent action was that Kelly Cooper, a city employee, has drafted a climate action plan that's posted on the city website and is available now for public comments. So to summarize and conclude, I showed you several takeaway messages. The first is that climate change is happening now, has happened already, and is causing severe and substantial impacts to both people and nature. The second is that we know greater warming and greater climate change leads to more severe impacts. But by cutting greenhouse gas emissions, we can limit that warming and avoid the worst impacts. And then third is adaptation is another action that can reduce impacts, but we've seen limited action to date, and adaptation actions need to be accelerated, as well as consider equity and development while doing so. But we also know that adaptation limits will be reached. And so this combination of mitigation and adaptation is important. And actually, I'd like to finish with a 4th takeaway message that I'll just quote from the summary for policymakers. I'll read the quote. Evidence of observed impacts, projected risks, levels and trends in vulnerability, and adaptation limits demonstrate that worldwide climate resilient development action is more urgent than previously thought. So thank you very much. I'd be happy to answer any questions you might have.
Thank you, Jeff, for that thorough and somewhat not only perplexing, but frightening message about the fact that it's already later than we thought it was. One of the headlines in the New York Times this morning said that we should have been putting this some of these plans together yesterday. And now we're having to play catch up if we're to mitigate the most serious impact of climate change. We had a couple of questions in chat asking about Moscow being the only city in Idaho who has a climate action plan, and I did put the draft, a link to that in the chat, along with the Moscow Pullman daily news story from the weekend. Those are good resources. We do have a question in chat from Ben, who is wondering whether the University of Idaho has a climate action plan. And I know anecdotally that there are some planning efforts underway, but Jeff or someone else, can you speak to the status of the U of I's climate action plan?
Yes, I haven't looked at that recently. I think there was a climate action plan developed that mostly addressed greenhouse gas emissions and how to cut them, which is typical of action plans. Action plans could be comprised of both mitigation options, that is reductions in greenhouse gas and energy use, but also adaptation actions, which are a little harder to think about and often harder to justify financially. But UI has produced regular greenhouse gas emissions reports. I don't know the year of the latest one. I think it's now a few years old. And I believe UI has an action plan, but like Kent, I think there's some interest in updating that.
And I'll try and get a definitive answer by next week's program. I know that the Sustainability Center has been heavily involved in those climate action plans, and particularly efforts to move us to some alternative energy sources like the solar array on top of the IREC.
Right.
So other questions, feel free to either unmute yourself and ask a question aloud, or to put a question into chat, and I'll try and keep tabs on those.
I see there's a few questions in the chat that I'll just answer. One is from Ginger Carney, who asked, is Idaho the only city with, I think she asked, is Moscow the only city in Idaho with an adaptation plan? And I don't know the status of adaptation plans per se, but I do know other cities are quite active in terms of climate action plans, which again include mitigation, reducing greenhouse gases, as well as adaptation. Boise has been doing a lot of work on that line, and let's see, Haley and Sun Valley are also active in that area.
Eric has a hand up, so Eric, why don't you go ahead and unmute and ask your question directly of Jeff?
Yeah, I prefer asking the questions directly. One local impact that I can think of that wasn't on the list that you presented was that the local wheat farms had terrible yield last summer. And how confident could you be that that is linked to the impacts of climate change?
Yeah, so thanks for the question. This is an example of an extreme event, a heat wave that has caused lots of damages. For scientists to be confident that human activities over the course of the last century have contributed in some way to this particular extreme event takes a significant amount of scientific study and effort. And so I haven't seen those. I've seen suggestions of studies that indicate that heat wave last summer was in part attributed to human activities, but nothing, I haven't seen a scientific study published in the scientific literature about that. But we know that just in general, that warming conditions lead to more heat waves. And therefore we would expect that there is this effect on not only crops, but pavement and heat-related deaths that will increase in the future associated with warming conditions. So the answer to the question is it's tricky and difficult to attribute one particular individual event. That has happened in some instances, but in general, we know that the heat waves will, and these extreme events will increase in the future given human activities that lead to more climate change.
Jeff, I might ask a little bit about the process. How did you get involved with IPCC? How long have you been doing this kind of assessment? And what's it like to be working with climate scientists in other parts of the US and maybe other parts of the world?
Right, so countries advertise for volunteers to help out with the assessment reports, the IPCC assessment reports. They are volunteer positions. There is support from the IPCC for some activities in developing nations, but obviously not from the US. And so I signed up, I nominated myself because I was interested in contributing and was fortunate enough to be selected. So the process is a consideration by the IPCC Working Group co-chairs and steering committee. to select individuals who they think can contribute in meaningful ways to the different reports. So I've been involved in this report. This is my first IPCC tour. That took 3 years. We actually started about 3 years and a month ago with a meeting in Durban, South Africa. I've been involved in other national climate assessments, for instance, and other local and state efforts. But this is the first IPCC event, and frankly, it's been amazing to get to know and watch these amazingly smart scientists who are brilliant and have worked so hard to put this report together. So it's been quite an experience for me.
We have a question from Gary Bryan and Nancy Cheney asking, in fast-growing states like Idaho, housing prices are climbing fast. Does the IPCC report address an array of housing as adaptation to accommodate climate migrants, to which I would add climate migrants to the Pacific Northwest in particular?
Not specifically, and part of the reason is because attributing migration to climate change, and as well as projecting what will happen in the future with respect to migration, is pretty tricky. Migration is a combination of a number of different factors. Climate might be one of them, but teasing out the rationale for migration could be driven by employment opportunities, family, et cetera. So my understanding is scientists don't know enough yet to be able to project what will happen particularly to migration. We can just sort of sit back and think, well, the Pacific Northwest is a place that's not going to be as hot and dry as California, for instance. And so, there are suggestions about what conclusions we can draw, but nothing reported in the IPCC report. So I'm not sure, I'm not really answering your question, Nancy, sorry about that, but it seems like it's a difficult problem, and we weren't that specific in the report.
Nancy, do you have a question, a follow-up question or a comment on Jeff's response?
Oh, well, I guess just the observation that he's correct. It's a challenging problem to address, but it's a growing issue and will continue to be, as people who are able to leave high-risk areas are doing so in numbers, and those who have limited options, who are the most vulnerable, are often pushed into areas without preparation. So either on their end or on the receiving end. So I think we're going to be reading a lot more about climate. Thanks so much, Jeff, for an excellent presentation.
Thank you, Nancy.
We've got about 5 minutes left. I wanted to give anybody who hadn't yet spoken a chance to participate. And here's one. And I apologize, I don't have the pronunciation, Subodh Adhikari. Thank you for the excellent talk. You mentioned potentially significant impacts on agriculture. Is there any evidence besides new crops or cultivars included in the AR6 report regarding agricultural adaptation? You want to tackle that one, Jeff?
Sure, I can comment a little bit. I assume what's meant is adaptation activities that will allow crops to survive or take advantage of the conditions, the new climate conditions in some areas. So I guess there's a whole sector chapter on food. So if you're really interested in this, I encourage you to read that. We talked a little bit about North America actions, some of which are the things that I did mention, were in places that are potentially benefiting from additional warming. Farmers can plant crops that they couldn't previously, or that might be more adapted to a warming, drying climate. Another adaptation action actually might be related to an indirect effect of climate change on pests and weeds that reduce damages, or sorry, cause lots of damages and reduce crop yields. And the climate is expected to increase the damages from pests and weeds. And so adaptation actions that limit those damages, that is, address those invasive species or weeds that reduce crop yields, are ways that we can reduce any future negative impacts of climate change to crop yields.
Before we wrap up, I wondered if I could ask Catherine Himes from the McClure Center to give us a quick preview of what to expect next week with our flash panel of 6 speakers looking at the economic impact of climate change on Idaho.
Kenton, I didn't know that you would call on me. I should be prepared for it because we're at a university. I was actually just about to leave for a different Zoom. But Kenton mentioned that next week we will focus on the Idaho Climate Economy Impacts Assessment. Jeff mentioned this during his talk. Jeff served as the co-lead of the forest section of that assessment. And it's really a look at what does climate change mean for Idaho's economy. So we have 6 major areas of the economy. And we also have information on what we call sort of foundational sections, Idaho's climate, Idaho's water, and smoke in the state. So Kenton mentioned we will have a bunch of lightning talks. We have Helen, who co-led the health section. Chris really focused on impacts to fish, different temperature scenarios in streams and rivers. Kelsey is a law student who's working with the McClure Center this semester. She's going to give an overview of the assessment. Pat led the agriculture section, co-led that. I'm going to be talking about recreation and tourism, and then Eric will speak about rangelands. He was the rangelands co-lead.
Well, great. Thank you, Catherine. We'll let you hop off for your next Zoom meeting and look forward to your presentation next week. But I hope that everyone who attended today can return, and that's a Zoom meeting, same time, same Zoom channel next week. And so before we let our guest disappear, let's put up our hands to thank him either on screen or with a hand up on the Zoom portrait. Jeff, you've given us a lot to think about, and we're grateful for your work on the IPCC report, but also lucky to have you as a resource here on campus for this important topic. So thank you all for joining us today, and look for you next week for more localized impact on the state of Idaho here on the results of what we might expect over the next few years. So again, appreciate Jeff. Stay well, everyone. See you next Tuesday.